All right, everyone. Sorry for this coming out a little later. Got a little busy earlier on today. All right. So this is first assignment in the trigonometry unit. This is all about angles, and this is kind of like a foundational assignment. Right. So I know we didn't go over this in class, but this is how you convert radians to degrees and degrees to radians. Right. And we did talk about that 180 degrees is the same as pi, or 360 degrees is the same as 2 pi, right? So you can use either one of those, but I'm going to go ahead and use 180 degrees is the same as pi. And what I'm going to do is multiply it right into here, right? So notice how this is 3.25 degrees. And if you make it into a fraction, this is actually 325 degrees on top. So what I'm going to do is I'm going to multiply this by something that's equivalent, right? So I'm going to multiply by the equivalents of each other. Basically a 1, right? So I'm going to multiply this by 180 degrees, and that's the same as pi, right? And notice that I chose to write 180 degrees on the bottom because 180 degrees, the degrees is on the bottom, which is going to cancel out with the degrees that's on top, right? And essentially, I just have 325 times pi on top and 1 times 180, right? So my final or my answer is going to come out to be 325 pi over 180, like that. Okay, and obviously I'm going to have to simplify this down a little bit. Okay, so thinking about what I can do with 100 for 325 and 180, and I'm going to go ahead and utilize my calculator to help me. All right, so 325, and I know I can divide 325 by 5, so I'll have 65 pi, and then 180, if I divide it by 5 as well, I'll have 36. So I have 65 pi over 36. Right? And then I'm going to see if I can reduce that even more. All right. So 65 pi over 36, and so you can check it out. What divides into 65? I don't know 5, but 36 doesn't divide into 5 because it doesn't end in 0 or 5. So I think I'm done, but I'm going to show you guys this feature on the calculator. Okay. So you may already know it or not, but I'm going to put in 65 divided by 36. Right. And when I hit divide, it comes out to be 1.8055555. Right. And then I'm going to use this feature under the math button on the very first option, right? Option 1, where it says arrow fraction. Okay, what I'm doing is I'm turning my answer, my decimal, into a fraction. And if I hit enter and it keeps it at 65 over 36, then I know that this is my final answer. So my final answer is 65 over 36, and then that's times pi. Right? So, and if you notice that I could have done that from the start. Okay, I didn't have to know how to divide it by 5. Okay, I could have done 325. Don't have to put in the pi. 325 divided by 180. I can just straight up divide that, right? And then I can just do the conversion, hit the math button, and convert that to a fraction, and I'll get 65 over 36. So I can automatically go from here, from this answer, to 65 pi over 36, right? So that's how you convert this 325 degrees into a radian, 65 pi over 36. Right? So you can use a calculator, and it can help you greatly with your time. So let's try it one more time. So we have 340. So I'm going to do the same thing again. I'm going to go ahead and 340. I'm going to go ahead and multiply 340 by 180, and I'm going to put 180 on the bottom because the 340 is on top, and then pi on the top. And the reason why I'm doing that is again, I want this degrees to cancel out with the degrees. So really, I have 340 pi on top divided by 180 on the bottom. Okay, and if I write that down, right, I can just do that into my calculator. 340 divided by 180, and I don't have to put in the pi. I just have to remember to put it in when I'm done, and that gets me 1.8888. Hit the math button, and you change that to fraction. Option one, hit enter, and it'll give me 17 over 9. So my answer is 17 pi over 9. That's it. Okay, it's that easy. Okay, number 3. Again, I'm going to use the same strategy. Let me get rid of some of this stuff. Okay. Use the same strategy for number 3. Okay. I'm going to do a little nicer this time around. So I'm going to multiply it by 180 on the bottom because the degrees is on top, 180 degrees. Then I'm going to multiply by pi on top. Okay, I can do 360 on the bottom and 2 pi on top, but that's just, that's doable. I mean, there's nothing wrong, but that's just a little bit bigger. Okay, I'd rather do it with a little bit smaller, which is 180 and pi, and these are equivalent to each other. Remember when we first started talking about radians? Okay, 180 degrees is the same as pi. Okay, and really what we're doing is we're dividing the same thing by each other, and when you divide the same thing by each other, you actually get a 1. So when you divide the same thing by each other, you get a 1, and when you multiply by 1, you really don't change what the thing is. 60 times 1 is still 60. So that's why we're able to do 180 divided by pi, or 2 pi divided by 360. But like I said, I'm going to use a smaller value, which is 180 divided by pi. Okay, and by doing this, I can cancel out the degrees, and essentially I have 60 pi on top divided by 180, or in my calculator, I can just write down 60 divided by 180. Okay, and that gets me 0.333. Math, convert that over to a fraction, and that gets me 1/3, or my answer, 1 pi over 3. Okay. Now, number 4, you notice that number 4, it starts off being a radian. So if it's a radian, I'm going to do it the opposite of what I have here. Okay, instead of pi over 180, I'm going to flip it around because I want to multiply it so that the pi's disappear. So I need the pi on the bottom, diagonally on the bottom, and then the 180 degrees on top. And notice nothing's going to cancel the degrees, so my answer is going to end up being a degrees. Okay, so I can do some work, but I'm just going to go ahead and use the calculator to help me. So on top, I have negative 4 pi times 180. Okay, or just negative 4 times 180. And on the bottom, I have 3 times pi. And again, oops, I forgot to mention, but the reason why I'm doing this is because I want the pi's to cancel. So I won't have any more pi's. So I really just have negative 4 times 180 degrees on top divided by 3 on the bottom. So on top, I have negative 4 times 180, just like that. And then divided by, and I have a 3 on the bottom. Okay, and that gives me negative 2 for 40. And that already is a degrees, because remember, the 180 is a degrees. So I get negative 240 degrees. Okay, that's it. Same thing here. I'm going to go ahead and multiply this by 180 degrees over pi. Okay, and again, the idea is that I want these pi's to cancel. So that way I don't have to worry about pi anymore. Okay, and by doing this, all I have to worry about is figuring out what 23 times 180 degrees is, and then divide it by 12 on the bottom. Okay, so on my calculator, I'm going to use that again. I'm going to put in parentheses because I want 23 times 180 to be done first. And then I want to divide that by the bottom, which is 12. And that gets me 345. And remember, the 180 is degrees, so my answer is going to be 345 degrees. Okay, same thing here. I'm going to put 180 on top, 180 degrees, and pi on the bottom. Okay, the idea is that I want my pi's to cancel. So on top, I will have 10 times 180 degrees. And on the bottom, I have divided by 3. So on top, I have 10 times 180 degrees and divided by 3 on the bottom. Okay, and I get 600. So this is equal to 600 degrees. And you can always check with Google. Google will, if you type in 600 degrees to radians, it'll tell you it's 10 pi over 3. Actually, let's check it out really quick. Okay, so so where's my Google? Okay, Google, Google.com, right? So and again, you can. This is a way to cheat, yes, right? Or heck, let's do it like this: 10 pi over 3, right? What is that in degrees? Or you can do 600 into radians. Okay, I'm gonna go ahead and do 600 into radians because I don't know if I know how to do 10 pi over 3 into the calc into the Google, right? So I'll just say, so I'm gonna type in 600 degrees to, and look, here's my first search for that, 2 radians, and it'll tell me 600 degrees is 10.472 radians. Um, Not really nice here. This isn't what I want. Mm, Click calculator. Let's see what this one says. Calculate. Oh, right here. See? 600 degrees is 10 pi over 3 radians, right? And right here, 600 degrees. So you can definitely use Google to help you a little bit, but 600 degrees is 10 pi over 3 radians, okay? And vice versa. Okay, so let me do a quick search again. Let's see if that works. Okay, I'm gonna go back. So let me see if I can actually type that in. So I'm gonna type in 10 pi divided by 3 2 degrees, right? Mm, okay, let's see what it says. Oh, right there, it tells you 10 pi over 3, right? Cosine 10 pi over 3 is 600 degrees. Okay, so pretty much the same. I mean, not pretty much the same. It is the same, but we've actually did some work here. Okay, so you can check your work if you don't think that your answer is correct, but I just show you 2 examples on Google how to find out the answer. And you could have always done that. Okay, but I think just watching through the video is much quicker, and you can see that I had a little trouble finding my answers. All right, so number 7, 570 degrees. I'm going to multiply that by, and since degrees on top, I'm going to use 180 degrees on the bottom and then pi on top. So when I'm multiplying it out, I'm going to go 570. And remember, the degrees cancel. So 570 over 180, right? And you can put in the pi afterwards. So 570 divided by 180. I'm going to hit enter. And then it's 3.1666. I'm going to hit math, convert to fraction. And that tells me it's 19 over 6 or 19 pi. Because remember, we still have the pi in there, over 6. Negative 315 degrees. Again, I'm going to go ahead and multiply by 180 degrees on the bottom and pi on top. Okay. What does that make? So when I put in my calculator, I'm just going to put in negative 315 divided by 180. Okay. Remember, you don't have to worry about the pi until you're done. So you get negative 1.75, or convert that to a fraction, because we do need the fraction. It's going to be negative 7 over 4, or negative 7 pi over 4. Okay, almost done with this first part. One more time. um, Pi over 2, I'm going to convert that. Well, actually, we already know what pi over 2 is, right? This is in our notes. We already know that pi over 2 is 90 degrees. Hey, but let's double check it, because we know this answer. Let's double check. Let's convert it just the same. So we're going to go ahead and convert pi over 2. We're going to go ahead and multiply this. And again, because this is already in radians, it's in pi. We want to get rid of the pi. So we want the pi on the bottom diagonally. And then we want 180, because 180 degrees is equivalent to pi. Right? And then what's going to happen is the pi's are going to cancel. And we, on top, we have 180 degrees. And on the bottom, we have 2. So we have 180 divided by 2, and that gets us, see, 90 degrees. That was our answer. Okay, negative 180. So this one, I already know the answer, or you should already know. We know that 180 degrees is the same as pi. We've been using that. And then it's just negative. So negative 180 degrees is just negative pi. Okay. Oops. So for these, wow, my numbering is already off, huh? From 1 to 10, and then 19, 20. Right, draw angle with a given measure in standard position. Okay, 280 degrees. Right, so I'm going to be talking out loud. So I know standard position is the initial side starts right here. And then let's see, that's 90 degrees. Okay, I don't want that. That's 180. I don't want that. Then plus another 90 is 270. Okay, which is almost 280. So I don't want that. I want 280, so which is a little bit more than 270. So 280 is probably like that. Okay, and I need to make sure I draw my angle. So my angle is starting at the standard position, and it's going to go in this direction. Okay, that's 280 degrees. Okay, now you could also have done this, but this wouldn't be 280 degrees. Okay, this right here, and since this is 10 degrees right here, right, because that's 270 plus 10, right? I could also do this, but this right here, this is a coterminal angle, but this would be equivalent to negative. Let's see, that's 90, so negative 80 degrees. Okay, and I don't want that. Okay, I want to show 280 degrees. So I want to do this right. So 90, 180, 270, and then plus another 10 is 280. So that's 280 degrees. And actually, I don't know about you, but I love doing these. Okay. So 710. Okay. So I know if I go all the way around, it's 360, and it's not 710 yet. Right. So that's not all the way around. So if it's all the way around and then another round, right? So I'm going to use my calculator. So how much is 2 full circles, right? So that's what I want to know. Hey, right, so 2 full circles. One full circle is 360 degrees. And if I add another full circle, 360 degrees, I get 720. Right? And I don't need 720. I need 710. So it is almost two full circles, but it's actually 10 degrees less. So I'm going to go one full circle, and then a second almost full circle, 10 degrees less. So I need that much. Okay. And so I need, so this right here, this will be my 710 degrees. So almost two full circles. It's 10 degrees less than a full circle. Okay. This is negative 120. Right? And just a quick note, this may not be exactly, but it is pretty close. Okay, so you don't have to draw exactly 710 degrees or 280 degrees. Okay, so it's pretty close though. All right, so negative 120. So negative means I'm going to go in the clock y direction. So if I go backwards this much, this is negative 90, but I need a little bit more. Okay. And if I go backwards another 90, it'll be negative 180. That's too much. So I don't need all that. So negative 120. So from 90 to 120 is 30, right? So 90 plus 30 is 120. So I need 30 degrees after 90. So this will be negative 90, and then I need 30 more degrees. So again, you're just gonna just eyeball it. Okay, it's gonna be about that much. Okay, because if you hit the middle, it'll be 45 degrees, and I need 30 degrees. So I would say this right here would be negative 120 degrees. 11 pi over 6. Okay. I don't know what that is. Okay. But I do know that if I do know, and I don't know, I know third period did not hear this, but in fifth period, I know Adam mentioned that, hey, you know what? If that was 12 pi over 6, right? What's 12 divided by 6? That's 2. So that'd be 2 pi, right? So if that was 12 pi over 6, that would be 2 pi, and 2 pi is a full circle or one whole revolution, right? But we don't have 12 pi, right? We don't have 12 pi over 6, which means we don't have a full circle. We have 11 pi over 6. And 11 pi over 6 is a little bit less than 12 pi over 6. So what that means is that we have almost a full circle, just about right there. Okay. So that would be about 11 pi over 6. Okay. Because again, Adam Sundberg said 12 pi over 6 would be equivalent to 2 pi. And 2 pi would be all the way around. But since we don't have 12 pi, we only have 11 pi over 6, which means we have a little bit less than a full circle. All right. Good job, Adam. Calling you out, bud. Or not that you did anything here, but I was really proud that you actually thought of that in class. Okay. And some of you guys may have thought of it in class as well, but maybe you didn't say anything. So that's why I'm not giving you props. Sorry. Okay. Find the measure of each angle and then convert any degrees to radians and any radians to degree. So all of this is kind of like what we did on the first page, just a mixture of it. Right. So let me look at this. So it looks like we've got, so we got that much. And then, so I know, so I'm going to go ahead and retrace this and do it in a little thicker line. So it looks like I've got 90, 180, 270. And then it looks like this is telling me that it's 80 degrees. So 270 plus a little bit more, which would be 200 and whatever, plus 270 plus 80. All right, so I'm going to utilize my calculator. So 270 plus 80 more degrees makes 350 degrees. Right, so what I have there is going to be 350 degrees. So I'm going to go ahead and trace that out and write 350 degrees. Okay, and 350 degrees, I'm going to convert that to radian. So I'm going to use 180 degrees on the bottom and pi on top. Right, and I'm going to utilize my calculator. So 350 divided by 180. That makes 1.9444. Convert that over to fraction, and that's 35 over 18. Or I'm going to write down 35 pi over 18. That's my radian. So 350 degrees converted over is going to be 35 pi over 18. Okay, let's look at the next one. The next one, all we know is that, you know what, this much is pi over 4. So it looks like I'm going backwards right here. Okay, it looks like I have negative 90. And if I went all the way to this right here, it'd be negative 180, right? Or actually, since I'm talking about radians, negative pi right here. If I went all the way, I would be at negative pi. but I need pi over 4 less than that, right? So I need to actually take pi, and I need to just subtract pi over 4. Let's just forget about the negative for a second, right? Let's just say pi, which is half a circle, and I need to take away pi over 4, right? And then when I'm done, I'll put a negative back on. Okay, so I'm gonna go with pi. I'll put blue this time. I'm gonna go with pi, and I'm gonna take away pi over 4, right? And to do that, I need a common denominator. I need a 4 and a 4. So I will actually have 4 pi over 4 minus 1 pi over 4, which makes 3 pi over 4. So that's my angle. But remember, I'm going underneath, so this will be a negative 3 pi over 4. Okay. And if I need to convert that to degrees, I'm going to go ahead and multiply this by 180 degrees over pi. And the reason why is because I want the pi's to cancel out right there, diagonal from each other. Just like how the number 23, I want the degrees to cancel out like that. Okay. So I have negative 3 times 180 divided by 4. Again, I'm going to utilize my calculator for that. So negative 3 times 180. Oops, I forgot to put parentheses. So I'm going to work this part first. Hit enter and then divide it by 4. And that's negative 135 degrees. So this is equivalent to negative 135 degrees. Okay. So far, my answer is 350 degrees or 35 pi over 18. Second one, my answer is negative 3 pi over 4 or, negative 135 degrees. Okay. Next one here. So again, looks like if I was to kind of trace this out, if I went, I would have 90 and I would have 180 degrees. But of course, I'm talking about radians because this is in pi over 6. So I would be, again, I would have half a pi and then pi. But since I don't need all of it because I need to go back pi over 6. Okay. So that means that I need to erase that pi over 6, meaning I need to subtract pi over 6 from pi. So this is pi, take away pi over 6. And again, I'm going to go ahead and get a common denominator of 6 here. So times it by 6, times by 6. So I will actually have, here, I'll work it out over here. 6 pi over 6 minus 1 pi over 6. Right? And 6 minus 1 is 5. So this answer here is 5 pi over 6. Okay, and converting that to, so that's my answer. Okay, but if I want to convert that to a degrees, I need to multiply this by, let's see, pi on the bottom because I need it to cancel out, and then 180 on top, 180 degrees. Okay, and then I'm going to use my calculator. I'm going to go 5. Sorry, I'm going to use parentheses this time. I'm going to go 5 times 180, close it off, and then divide it by, so 5 times 180 and then divide it by 6. And that gets me 150. And then again, the pi's cancel out. So I am left with just degrees. So my answer is 150 degrees. So that's my degree answer. So 5 pi over 6 is my radian, and 150 degrees is my degrees. Okay. Let's see. This one looks pretty easy. This one, I'm going backwards, so 90, 180, and then if I went all the way, it would be 270. But I need 20 less, right? So that's what it says right there. So it'd be 180 degrees Sorry, not 180 degrees. 270. I don't know what I was thinking. 270 degrees, which is all the way around to here. Okay, so 270 degrees, and I need to take away 20 degrees from there. Which you can do this without using a calculator. You get 250 degrees. Okay, that's my answer. Okay, but if I need to convert that to a radian, I need to multiply this by pi over 180 degrees. Again, the reason is because I want these degrees to cancel, and the pi's don't cancel. That's why I'm left with a radian. So using my calculator, 250 divided by 180 gets me 1.3888. Turn that, hit the math button, change it to a fraction, and you get 25 over 18. So my final answer is 25 pi over 18. Oh yeah, you can just see it here. If you can cancel the zero out, you get 25 over 18. Okay, and that's my radian answer. I'm gonna move this over a little bit. Okay. All right, 27. Let's see. So this is in radian. So I'm gonna kind of try to follow this through. So if I started here, it looks like it's going backwards, which means negative. So this would be negative 90, negative 180. But I'm talking about, so we'll say degrees for now, but right, negative 270 and then negative 360. So I went a full circle, right? And then it looks like I'm going to add another 90 degrees. But then they want me to. So if I went there, it'll be a full circle backwards and then another 90 degrees. Okay. But we don't want the full, we want to erase that part. Okay. And how much is it? That right there is pi over 3. So we only want that much of it. Okay. So going over what I just said, we went over a full circle backwards. Okay. But I was talking about degrees, but this is in radians. So a full backward circle would be negative 2 pi. Okay. So going a full circle backwards, doing this. Okay. Made a full circle. Okay. Now, so I know this is a little weird, but some of you guys might be thinking, well, why don't you make a circle? I could, I could do this. That's a full circle, right? But I need to keep going. So that's why the circle is not complete, or we don't make it a complete circle. We kind of offset it. So we kind of draw a full circle off to the side because we need to keep going. All right, so that's why it looks like it's a little bit messed up circle, but it is still a circle. So I'm going backwards negative 2 pi, which is a full circle, and then I'm going to go ahead and add another negative 90 degrees, or in radians, it's going to be another negative pi over 2. Okay, so I went backwards a full circle, which is negative pi over 2, and then backwards a a quarter of a circle, which is negative pi over 2. But then I need to go ahead and go forward, right? I need to go forward because if you think about this, this is going. So right now I'm back here at negative pi over 2. But then now I need to go forward. So I need to go positive that much. So I need to do a plus pi over 3. Right? So all of that you can do it together. Okay? So that looks like a lot, but you know what? We can do it. All right. So go ahead and put a denominator on that 2 pi, and I need to get a common denominator with all of these. Okay, between 1, 2, and 3, I think I need to get a 6. So I need to times this first piece by 6, which means times that by 6. I need times this piece by 3, which means times that by 3. And I need times this piece by 2, which means times that by 2. Okay, so my new problem is going to look like negative 12 pi over 6. That's what I have right here. Okay. Negative 6 times 2 pi is negative 12 pi over 6. Okay. And then this piece right here, I have negative 3 pi over 6. And then this piece right here, I have plus 2 pi over 6. And now they're all over 6. And now I'm just going to go ahead and add negative 12 pi minus 3 pi. So 12, 13, 14, 15. So negative 15 pi. And then plus 2 pi. So that means I'm going to go backwards or go forward. So plus 2 pi. So negative 15 plus 2 is negative 13. So my final answer is negative 13 pi over 6. Okay, and that's my radian measure. Okay, and that's for this much, right? A full circle and then a little bit more. That's negative 13 pi over 6. Now I need to convert that to a degree, so I need to use my pi at the bottom and 180 degrees on top, which means that I'm going to have my pi's canceling. Okay, and again, I'm going to use my calculator. I'm going to multiply negative 13 by 180 and then divide it by 6. So, parentheses, negative 13 times 180. Close that parentheses because I want that to be worked out together, and then divide it by 6 afterwards. And that gives me negative 390 degrees. So the answer is negative 390 degrees. Those are my two answers right here. Okay. And if you think about this, yeah, it actually does make sense. Okay, if I'm using a degrees, right? Because if I go backwards, right, backwards 90, negative 90, negative 180, negative 270, negative 360, and look, we're at negative 390. So negative 360, and then plus a little bit more. So that's 30 degrees more. So that's negative 390. Okay. So it looks good. Okay. Leave it there for a second. Okay, 28. Wow, this one looks crazy. Okay, this one looks like I'm looking at positive angle. So let's see. If I go one whole revolution, then that's 2 pi, right? Since we're talking about radians here, that's 2 pi. Then it looks like I'm doing another full circle. That's another 2 pi. So far I've got 4 pi. And then let's see. It looks like if I can do that 90 degrees or pi over 2 plus a little bit more, that'd be great, but I don't know how much more that is. So what I'm going to do is I'm going to go ahead and say, okay, so far I got 4 pi or 2 whole circles. I'm going to go ahead and do a whole pi, which is the 180, right? So plus pi, and then I'm going to go backwards. I'm going to go backwards 5 pi over 12. And that's where I end up here. So if I go backwards 5 pi over 12, that means that I'm actually going to be subtracting. So I end up right there. So I'm going to subtract 5 pi over 12. Okay, so, well, I'm going to go ahead and kind of cut to the chase. 4 pi plus 1 more pi is 5 pi. So I'm going to make that easy for myself. So 5 pi minus 5 pi over 12, right? So let's make that easy for ourselves. Okay, so we've got 5 pi minus 5 pi over 12. Okay, and you can't just add those or subtract those like the way it is, even though they look pretty similar. Okay, we still need a common denominator. So we need to get a 12 at the bottom. So I need to multiply this by 12 and this by 12. So I'm going to have 60 pi over 12 minus 5 pi over 12. And 60 minus 5 is 55. So my correct answer is 55 pi over 12. Okay. And now I need to convert that over to a degrees. How much is that in degrees? Well, for degrees, I need to have, since my pi is on top, I need to put a pi on the bottom diagonally so it can cancel. And then you know that 180 is the same as pi in degrees and in radians. So they're equivalent. So I'm going to go ahead and do that. And by doing this, we've canceled out the pi's and we're left with the degrees. So in my calculator, I'm going to go and do 55 times 180 divided by 12. Okay, I'm going to put that in parentheses. 55 times 180 divided by 12. And I'm pretty sure if you don't put parentheses, it'll still be correct. Let's just check it out. 55 times 180. Yep, same thing. 825. Right? So 55 over 55 pi over 12 is the right answer. Or what was the answer again? 825, right? Or 825 degrees is also the answer in degrees. Yeah. All right, almost done, guys. 29 and 30. Okay, I'm going to go ahead and erase all that. You can always rewind or drag drag it back to where I'm working on it if you ever need it. Let's see. Okay, so this one helps. This one's pretty nice. Okay, this one shouldn't take too long. So this tells me that this is 170, right? So that means that little piece down here, which I don't know what it is, that's going to be 10 degrees because I know 180 is half of the whole circle. So if I take off a little bit, that's 170. So that means that little piece is 10. Okay. So this one will be easy. So this is going to be one whole circle. So that's 360 plus another 10 is 370 degrees. So this one's easy. So this is going to be 370 degrees. That was pretty easy. Then I need to convert that to a radian. So that's going to be 180 degrees on the bottom. Oops. And pi on top. And again, the reason why I set it up that way is because the degrees will cancel with each other. Okay. And then all I have to do is figure out what 370 divided by 180 is. And I'm going to use a calculator for that. 370 divided by 180. That gets me 2.0555. Convert that over to a fraction, and that's 37 over 18, or 37 pi over 18. Double checking it. Yep. Okay. So my correct answer is 370 degrees or 37 pi over 18. And you can always check with Google if you're not sure. Okay. Last one. Let me see. This looks like, let's see. I'm going backwards. So this is going to be a negative angle. So it looks like I'm going backwards one full circle. So negative 2 pi. Then it looks like I'm going backwards another full circle. So another negative 2 pi. So far I got negative 4 pi. And then this one's pretty nice. This tells us that little piece that I have, that's pi over 3. Right? That piece is pi over 3. So I need to go backwards another pi over 3. Okay? So altogether I have negative 4 pi. Because negative 2 pi and negative 2 pi is negative 4 pi. And I need to subtract pi over 3. Okay? Get a common denominator. So times this by 3. And times this by 3. And I have negative 12 pi over 3 minus 1 pi over 3. So negative 12 minus 1 more makes negative 13 pi over 3. Okay, and that's what this angle up here is, negative 13 pi over 3. Okay, I'm going to go ahead. Oops, where's my eraser? So I'm going to go ahead and write that down. Up here is negative 13 pi over 3. Okay, and what's the degrees? Well, I have to convert this over. So to make a degrees, I have to put a pi on the bottom because there's a pi on the diagonal top and 180 degrees on the top. Okay, again, the reason why is I want the pi's to cancel, so that way I get out of the radian and I get into the degrees because I will have degrees left over. So on my calculator, I need to go and do negative 13 times 180 divided by 3. Okay, so negative 13 times 180 divided by 3. And I just showed you guys that the parentheses didn't matter. Okay, if you want to be extra careful, you could, but it's not going to matter. And I'm going to get negative 780 degrees. So this is equivalent to negative 780 degrees. And these are my two answers. Okay. And 31 to 34 is find the complement and supplement. Right? So 30 degrees. So just a brief explanation. If I'm looking for complement, it's out of 90 degrees. So if I have 30, if I have 30 degrees, how much more till I get to 90 degrees, right? So the complement is going to be 60 degrees because that's just 90 degrees minus 30 degrees, which makes 60 degrees. Okay, so this will have to be 60 in order for it to be 90. Right? So that's the basic idea. Take the complement, which is 90, and subtract what you have. Right? And in the case of supplementary, right? And again, this is what it looks like. Supplementary is 180 degrees. So far I have 30 degrees. Okay. How much more do I need until I get 180 degrees? Right? So the supplement. So how much is this right here? Well, this has to be 150 degrees because supplementary is going to be out of 180 degrees. Okay. You can also go and do 180 degrees minus the 30 degrees that they give you, and you can get 150. So the supplement is 150 degrees. The complement is 60 degrees. Okay. So I may not be drawing the pictures anymore. I will just subtract that from the 90 or the 180. Okay. So 85 degrees. This one's pretty easy. Complement. So I will go for the complement is 90 minus 85, which gets you 5 degrees. And for the supplement is 180 minus 85. Right? So use a calculator, or hey, you know what? Let's do this old-fashioned way. Right? 0 minus 5, I can't do that. So I need to borrow. So I need to borrow from the 8. Or actually, I'm going to borrow from the 18. So it's gonna leave me with 17. So I'm gonna borrow 1 from the 18, and it's gonna leave me with 17, and I get 1 next to the 0. So now I can do 10 minus 5 is 5, and then 17 minus 8, right? So 8 from 17 gets you 9, and that's gonna be 95 degrees, just like that. Okay, these are a little harder. Okay, same idea, but it's going to have to come out of the complement pi over 2 and the supplement pi instead of the 90 and the 180. Okay, so it's a little harder because it's not as easily recognized as degrees. So, all right, so for pi over 3 for the complement, okay, so for pi over 3 for complement, it's going to be out of 90 degrees, but in radian, it's going to be pi over 2. And I'm going to go ahead and subtract pi over 3, just like how I did earlier. Okay, except fractions, I like to do it this way. So that way I can get a common denominator. But it's up to you how you want to do it. So I'm going to times it by 3 to get a common denominator, and times it by 2 to get a common denominator. So I will have 3 pi over 6 minus 2 pi over 6. So 3 minus 2 is 1 pi over 6, or just pi over 6. So that's my complement. My supplement, okay, is 180, but again, this is in radians, so I'm not going to use 180 degrees. I'm going to use pi. Right? And just like how we did with number 32, it's going to be pi minus pi over 3, just like that. But again, with fractions, I like to do it sideways, next to each other. Okay, so by doing this, I know that I need to get a common denominator of 3. So times 3 times 3. Right? And I don't need to do anything over here, so I will have 3 pi over 3 minus 1 pi over 3. I don't need to write the 1, but if you want to write the 1, you can. Right? And 3 pi divided by 3 minus 1 pi divided by 3 makes, and 3 minus 1, 3 pi minus 1 pi is 2 pi over 3. Okay. Last one, pi over 4. Again, complement. If we were in degrees, we would take 90 and subtract, but since we're in radian, we're going to go ahead and take pi over 2, okay, and we're going to go ahead and subtract that angle, which is pi over 4. Okay, and again, with fractions, I like to do it side by side like that, and I'm going to go ahead and get a common denominator. I need 4, so I just need to multiply this by 2 and 2, and I will have 2 pi over 4 minus 1 pi, which is pi over 4. And 2 pi minus 1 pi leaves you with 1 pi, or just pi over 4. Okay, that's my complement. My supplement is, again, same idea, except instead of pi over 2, because 90 degrees is complement, supplementary is 180 degrees. But in terms of radian, we're going to have to use pi. Okay, refer back to your notes. Okay, pi and 180, which is the supplement, is going to be the same. Again, doing it side by side allows me to think about it in terms of common denominator. I need to multiply this by 4, right? And I will have 4 pi over 4 minus 1 pi, or just pi over 4. And 4 pi minus 1 pi makes 3 pi over 4. That's my supplement. All right. That is a wrap, guys. I know this was a super long video. I don't know how long, but probably nearing an hour. Okay.